please welcome Simona and Asim, who will talk to you about how to deploy and secure your application to the Azure cloud. So please warm up, encourage them, please. It's your turn.
Can you hear me okay? Yeah? Did you also think that that was something that you can sit on? Yeah? Cool. Bonjour. I'm Simona Cotin. I work as a cloud developer advocate for Microsoft.
Hi, my name is Asim Hussain. I also work as a cloud developer advocate at Microsoft.
Oh, wow.
Yeah. Oh, what coincidence.
So what do we do there? Apart from traveling to awesome places like Nantes, we also want to make the JavaScript community happy on Azure. What else do we do?
Yeah, we make the JavaScript community happy on Azure. So if you've got any issues or complaints about Azure, go speak to Simona afterwards.
Or to Asim. Yeah. Cool. Thank you. So today we're going to learn how to deploy an Angular application using GitHub and Circle CI to Azure. And then Asim is going to show you how to secure your application with some real life stories. Super cool. Looking forward to that one. How many of you here are Angular developers? I can see a few hands. Quite a lot of hands there. Cool. So I guess that you do know Igor Minar, right? Last week I was at Angular Mix, and I got the chance to speak to the Angular team and also see some of the presentations that they've done. And one of the most interesting ones for me was a presentation that Igor Minar worked on. And he talked about software engineering as a discipline. And a very interesting thing that really stuck with me was the fact that he was looking at software engineering as building the invisible. And what he meant by that was basically when you're building like houses and architecture as a discipline, you're seeing what you're building. When you're building cars, you see things happening while you're doing stuff, right? Whereas when you're building software, you might have an UI, but that's not always the case. And UI is not as tangible as a car or a house is. So for us, it's actually quite hard to develop a discipline and to develop a certain behavior while we're building software. And there's a few issues that we might have, or a few things that might skip. And things like works on my machine, that's something we've all heard, right? How many of you have said that before? Works on my machine, what happened to you, Asim? What did you do to yours? Or we haven't changed anything, like my code was exactly the same yesterday at 5 p.m. when I left work, and now it's not working anymore. So there's way to address these kind of problems. Obviously, there's not a full solution to this yet. Or if you know one, do tell me. But definitely, CI/CD can help you address some of these issues. And let's see, what does CI/CD stand for? Couldn't I cared less? Does that make sense? Did you hear that before? Yeah? No? Did you hear about continuous integration and continuous delivery, though? Does that sound familiar? And did you feel like this the first time? You've heard about continuous delivery, continuous integration. Well, my role today, or my goal today, is really to debunk or to make you feel better about continuous integration and continuous delivery. And I'm going to debunk myths like, oh, CI/CD is scary. Like, that's not something that I'm meant to do. That's something that the DevOps team should do. Or do I need like mad terminal skills? Do I need to be able to code in the dark? I'm going to show you how easy it is to just use tools like Circle CI and a nice UI, write just a few lines of code, and be able to trigger a build and run your tests and deploy your product just by writing a few lines of code. And so when we're talking about CI/CD, one of the first things that we should be very careful and keep in mind is automation, right? Automation is at the heart of continuous delivery pipelines. And there's a few things that we want to automate. And the first one is our build, because we don't want to rely on a single person. Has anyone heard about the bus factor? When basically you're hoping that your one person that does the build does not get hit by a bus, because you won't be able to do that thing anymore. Yeah? Well, we want to make sure that we can build our code once anyone checks in code on GitHub, for example, or Bitbucket. We also want to make sure that we're running tests in an automated manner, because we want to be confident about the code that we're deploying to production. And we also want to be able to deploy our code to different environments in an automated manner. Like, you want to deploy your code to a testing environment, to a staging environment, to a production environment. So there's a few ways you can get started with this. You can use, you can write your own shell scripts that will help you automate everything. But there's also tools that can help you do this faster. And there's tools like Circle CI and Travis and Jenkins and VSTS. And you can choose between self-provisioned in-house servers, use Jenkins, or you can use SaaS solutions. But my favorite one is Circle CI. And the reason for which it's my favorite one is because the UI is actually super simple, and it's also free for open source projects. So if you're building your own projects and pet projects, or even if your company or your startup is implementing open source projects, you can use Circle CI for this, and you'll have a free tier. So that was the theory. And let's go ahead and see how we can actually do this using Circle CI. So the first thing that you want to do is go to circleci.com and sign up for an account. And there's a few options here. You can either use GitHub to sign up for an account, or Bitbucket, or you can use Google to just explore what you can do with Circle CI. And I like GitHub. And since I've already signed up for this and I've ran some projects here, I'm going to be redirected directly to the dashboard. But the first screen that you're going to see when you're signing up with GitHub is a screen that will ask you if you authorize Circle CI to read all your GitHub data, like your public and private repositories, your issues, your code. And for a moment there, I was quite scared about this, because I do have access to the Microsoft repositories as well, and I wasn't sure if I meant to share that. So I just created a new account. Circle CI at the moment doesn't allow granular access to Circle CI to repositories. So I created a new account, and that's what I'm going to use right now. And so we're in the Circle CI dashboard. We can go to Project. And this is where you're going to have listed all the projects that you've previously built. And in order to add a new project, you click Add, and then you start adding projects. Like, you click Setup Project. And there's a few options here. You can choose your operating system, and you can choose between Linux and Mac OS. And then, because I like Linux, I'm just going to choose Linux. And then there's 2 versions of Circle CI. The second one is faster, so we're just going to go with that. There's a few languages that are supported, like Go and Java and Node. And because we're JavaScript developers, we're going to use Node.js. And then Circle CI tells us what we need to do to set up our project. So we need to create a folder, .circleci, and then create a config file. And there's already a sample here that we can get started with. And this sample, this config file, is actually a collection of jobs that runs on a certain version of Circle CI, so in our case it's 2. And in this collection of jobs, the most important job that you need to run and you need to have, it's required, is the build job. And that's your main entry point to your run. And this build job is a collection of steps that's going to run somewhere. So you can choose between a virtual machine and Docker. And the difference between the two is that with Docker, your startup time is going to be instantaneous, whereas with a virtual machine, it's going to take between 30 seconds and 1 minute to get started. But you're going to have more access, like you're going to have sudo access, and you're going to have more power when using a virtual machine. But I'm going to go with the Docker, right? And Circle CI has a set of pre-built machines for us, hosted on Docker Hub, and you can go ahead and just use those. And then the steps are basically a collection of commands that we're going to run. And there's a few ones that are already defined by Circle CI, like checkout, which basically goes to GitHub and checks out your code, because that's what we want to build, as well as restoring cache and saving cache. Like this is an important thing. With Circle CI, you can save time by caching your node modules. And we do save this cache by just running checksum on package.json, and then we install our npm dependencies. But really, how do you build your application with Angular? Do people here use the Angular CLI? We have like half the room here using Angular CLI. So what we're going to do, instead of just running a yarn test, we're actually going to use the Angular CLI for building our application and running our tests. And so I've just opened VS Code, and I'm going to zoom this so that everyone can see it. And this is just the configuration that you've seen a few minutes ago. And instead of using the Node.js, the standard image with just Node.js, I'm going to use the image that also has browser so I can run my tests. And I'm going to run ng build for production, and this will enable my build to be my code to be built for production with AOT and tree shaking and all the goodness, all the optimizations that the Angular CLI will give you. And we're also going to run our tests, and that's going to be a single run because we don't want to keep our process, like we don't want to wait for changes. We're not going to change anything during our run. And then we're not going to show any progress because we're pretty confident that everything's going to go well every single time that we're going to check in code, right? That's what always happens. So this is all the config that you need to add to Circle CI to build and test your Angular application. And you can go ahead and just check in this configuration in GitHub, in your project, and then go back to Circle CI and just start building. So just to make this very clear, I do have the Circle CI project on GitHub. And that's where Circle CI is reading from. So once we've started building our project, you can see that we've been redirected to a new page where we will see information about our current build, like the status. Is our build running, or is it just started, or whatever? Is it finished? When did it started? 33 seconds ago. How much time does my build usually take? And that's important. We want to make sure that we keep our build to a very limited time, right? We don't want to spend a lot of time and resources. And it's good to have an estimation of how long our build has taken. Or whenever it takes double the amount of time that it used to take, then that's a problem, right? You also can see how many containers are you running in parallel, and in my case, it's just one container. And then you want to see like who triggered this build and which was the last commit that we're building. And then if we scroll down, we're going to see things like the steps that we've just defined in our config YAML. Like we can see that that spinning up the environment, like just starting Docker takes 2 seconds, close to nothing. Checking out our code at 0 seconds, has it really checked out my code? Restoring cache, like if you've built this before, it's going to find the cache, and this is what happened here because I've built this project before. And then you can run install and saving the cache and building and testing our project. And it has built successfully, which is awesome. It only took 1 minute, right? Cool, so what's the next step? Like right now, we have built our project and tested our project. So how do we deploy? Well, we can use different providers. We can deploy our project, we can put it into production on maybe on-premises server, or we can just deploy to the cloud. And I think that like cloud is very popular right now. Like how many of you are deploying your application to the cloud? That's a few hands, right? I think it's a third of the room, maybe. Are the rest of you just deploying on premises? Okay, that's another third. We're missing some people there. Cool, but like you have different providers. You can use things like AWS or DigitalOcean or Heroku, but my favorite one is Azure. And Azure has Azure App Service, which is basically a fully managed platform where you can deploy web apps. And I like the fact that it's fully managed because that just means that I won't have to install the operating system and patch it and do all the grunt work. I just need to deploy my code and that's it. And it also takes care of things like auto-scaling and load balancing. And that's very important because obviously when you have or when you're expecting your application to become very popular and have like a gazillion users, you need to make sure from the start that your application can auto-scale and do load balancing. So let's see how we can deploy this to Azure. Well, first of all, let's go to the Azure portal and see how we can create app service. It's actually super easy. Has anyone seen the portal before? Okay, cool. I think that's 10 hands, maybe. So we just click plus, new, app service. We search for a web app, and then create, and then you need to give it a name, and let's say DevFest Nantes. And this is going to be your URL where your application is going to be deployed, and then you have to choose your subscription and group, like create a group where all your resources are going to live. And then you can choose between Windows and Linux, and just then like maybe configure like where you want to deploy. Do you want to use Node.js as a server, or do you want to use some other things, right? But I've already created this, so I'm not going to go ahead and click create. I'm just going to go to my other application, and you can see here the URL. I'm going to have to add index.html here, and it says hello world. So what we want to do is add a deploy step to Circle CI now. And how do we do that? Well, I do have this other project where I've already done this. So we add a new run command, and we're just running this publish script that does just a few things. It just checks out the repository from Azure, and then it just pushes the new code. It copies the code that I've just built in our dist folder and copies it over to Azure. And I'm going to run a quick change here, just like DevFest Nantes. OK. Save this. push it to GitHub. And what this will do is trigger a change in my Circle CI project, trigger a build, run all the steps, push my code to Azure, and then we'll be able to see our application up and running. We've already seen this dashboard, so I'm just going to go back to the slides until this ends. And like in summary, what we've done, we've built our application using the Angular CLI. We've pushed changes to GitHub, and then those changes are being kind of monitored by Circle CI, triggered the build, and deployed the application to Azure App Service. And everything is handled automatically by just a few lines of code. And I think that's very powerful, because that just gives me the opportunity to just write code and make sure, and gives me the confidence that whenever I'm deploying code to my users, tests are going to pass and the build is going to pass. So I hope that now you're not feeling as stressed as you were feeling before when you heard about CI/CD. And my friend Asim is going to come on stage and teach us how to secure our application.
Awesome. Hello. Let me just attach something securely. Hi, so thank you very much. My name is, I was introduced before, my name is Asim Hussain. I'm a cloud developer advocate at Microsoft with my colleague Simona. She just showed you how to build and test and deploy your application to the cloud, to Azure. And what I'm going to talk about as well is once you've actually deployed your application, you need to keep it secure. And I'm going to talk about security, or I like talking about security, by talking about real life, okay? Not just about, in this situation, I would do it this way, but let's really talk about real life hacking stories, what's actually happened, how they got hacked, and what they should have done or to secure it, and what you could do to secure your apps in a specific way. Now, some of the stories I'm going to talk about are, or perhaps I can relate directly to Angular, and some of them are just going to be more general web development, but all of them are going to be applicable to anybody building web applications. So, who here has heard of the Equifax hack? Wow, I really can't see. Maybe like 20–30% of the audience. So, the Equifax hack was something I think earlier on this year, maybe March, May, I can't remember. So it was actually the largest hack in history. About 200 million people were affected, and Equifax is a $1 billion company, right? I mean, it has 10,000 employees. How did they get hacked? And what happened? But just to talk about that, let me just first explain a few terms. Who's heard of the word or the term zero-day exploit? A good number of the audience. Excellent. So a vulnerability is a hole in your security. So for instance, not setting up a firewall is a vulnerability. Okay? An exploit is a piece of code or even just a sequence of commands that you execute which take advantage of a vulnerability to do bad things. Okay? And a zero-day exploit is an exploit that no one knows about yet. It's a secret. If you are, Once a zero-day exploit becomes known, let's say you're a white hat hacker and you found a zero-day exploit and you contact the company, you tell them about it, it stops becoming a zero-day exploit. It becomes in the public domain, and you won't call it you wouldn't call it like this, but you might call it a 30-day exploit or a 6-month exploit or something like that. So how hard do you think it would be to get hold of a zero-day exploit? Yeah, pretty hard, right? I mean, you need to be the right people in the right circles. There was a study done, I think, last year, where they tried to estimate kind of how much a zero-day exploit costs, and because you don't really know, right? But they believe that the average price of a zero-day exploit was $250,000, as in you could sell a zero-day exploit for $250,000, because nation states and criminal agencies are very interested in zero-day exploits. But how hard do you think it would be to get hold of a 6-month exploit? It's really easy. It's incredibly easy, actually, because once it's in the public domain, it means it's available, it's online, there's various sites you can go to. Did Equifax, the largest hack in history, did they get hacked with the zero-day exploit? No. They got in through a known vulnerability in Apache Struts, which is a Java web development framework. It was a known vulnerability, a known exploit. They'd already patched a fix 2 months previous to when they got hacked. Okay? All that Equifax had to do to protect themselves was to install an update. That's it. That's all they had to do was install an update, but they didn't. And that resulted in the largest hack in history, and pretty much everybody, including my data, is now available, because I did a scan with Equifax once, is now available on to lots of agencies. So the solution is really easy, right? Just to keep everything updated all the time. But my job's to write code. Yeah? My job's not to keep all the software updated on the servers all the time. So I probably don't update stuff as much as I should, and you probably don't update stuff as much as you should. So that's why I like to make it someone else's responsibility to update my software. And Simona covered this briefly. We talked about on-premise, which is where kind of you're in charge of your hardware, you're in charge of updating your operating system, and you're also in charge of your own application logic. Okay, so if the hard drive fails, you fix it. IaaS is where you might use Azure or Google Cloud or AWS, and you basically get a VM. So if the hard drive fails, it's someone else's responsibility to fix it. But it's still your responsibility to keep the OS updated and then again your application code. And then we have PaaS, Platform as a Service, where it's someone else's responsibility to deal with the hardware, and it's also someone else's responsibility to keep the OS patched and the web server or whatever else that you're running. So I like to use PaaSes, and that's what Simona showed you earlier on with Azure App Services. That is our PaaS offering. We also have an IaaS offering, but Azure App Services is our PaaS offering. You're basically making it someone else's responsibility to keep all your software updated. Oh yeah, and there's a bunch of them. So Heroku is another PaaS. We've got Amazon Beanstalk, Google App Engine, and of course Azure App Services, which is at the top for a reason. And also one of the coolest things about Azure that I really like is something called the Azure Security Center. So when trying to figure out ways of alerting you on security, there's loads of different signals you can listen to. You can listen to a failed login attempt, and if that happens, send you an email alert. You can listen to a whole bunch of different signals. But that actually generates a lot of noise, and if we just alerted you in each of these individual signals, you just start ignoring all of your alerts. So what we did was we trained an AI. So we took lots of data, and we said these signals are from real hacking attempts, and these signals aren't. We trained an AI which detected which signals were more likely to be from real hacking attempts, and also which signals chained together are more likely to be hacking attempts. So if you actually look at the Azure Security Center, you can actually see a hacker's path through your platform. You can see, oh, we seem to detected some failed logging attempts, and then something looks like a SQL injection attack, and then some people are making connections to your server from locations that we don't recognize. So it's quite nice, and it's pretty easy to set up. You just click a button, and it's running. So I just set it up. So does anybody watch this show? 2, 3, 4 people. I asked this question a couple of times, almost every talk. Everybody should watch this show. It's my favorite show in the world. It's called It's Always Sunny in Philadelphia. It's a comedy show. And this is a guy called Charlie Kelly. He plays the dumbest character in the show, really, but also the funniest, I think. He cleans the toilets in the bar that they own, and he also kills rats. But he also thinks that he's a lawyer. So every time he gets into trouble, which is quite often, he represents himself in court really, really badly. And that's what I think about. That's my closing arguments. So thinking that you can create a secure platform when you're not an expert in security is like thinking you can represent yourself in court when you're not a lawyer. Okay, so use a PAS, make it somebody else's responsibility to make your platform secure. So that was kind of the first kind of real-life hacking story that I wanted to talk about. This is the second. While I'm taking a little quick zip of this code, maybe try and have a think about what this code is doing on the screen. So I seem to be getting getting the environment variables and then converting it into, well, a buffer, really. Nothing special. But what's this code doing then? You've got quizzes now. You've got to think. I'm just waking up. So I seem to be taking that environment variable. Oh, this is my server. And I seem to be, posting your environment variables to my server. Who here stores secret keys, passwords, connection strings in environment variables on their server? A couple of hands. Okay, so what if I told you I could make you run this code on your server? What if I told you I could make you run this code and give me all of your environment variables for your server environment? Would you believe me? No? Maybe not. Maybe if I showed you a bit more. So the file seems to be called packagesetup.js. No? Still don't believe me? What about this now? So it looks like, actually, if you look close at the code, it looks like it's an NPM package. So actually installing this NPM package, just the act of installing it, you're going to send me all of your environment variables. But I know what you're thinking. You're probably thinking, yes, okay, Asim, fine. If I installed your NPM module on my server, okay, you're going to give me I'm going to give you all of my environment variables. But why would I ever install your fake NPM module? Who saw this? It's kind of like 2 months ago now. Who saw this tweet on Twitter? Oh, I really can't see anything. Yes. So this is, Kent Dodds has a NPM module called crossenv. And Oscar discovered that someone else has basically created a fake module. Now, the difference was this. So the real one is with the hyphen. The fake one doesn't have the hyphen. Okay. It's called typo squatting. Okay, it turns out it's quite common, and not even just in Node, it's quite common in a bunch of languages out there. Just having a slight misspelling of the module name. Crossenv is downloaded about 1 million times a day. Okay? So how many of you, when you're sitting down, you're doing your npm installs, I've done it so many times with Angular, it's unbelievable. You can't quite remember the module name, so I'll try it with the hyphen, without the hyphen. Oh, it worked, excellent. And you carry on developing, right? You're just happy as anything. Maybe this should worry you a little bit more. And if you think about it, when you're running npm install, you're basically giving somebody else the right to run code as if it's you, as if you wrote the code. This goes past behind your firewalls, this goes behind any security procedure that you're running, that you can have. This goes behind all of that. And why do we do that? I thought about this thing a lot, because this really shocked me when I first discovered it, because the interesting thing about when you're looking at security is the attacks come from really interesting vectors. But as you become more used to it, you become more cynical. But this one really took me, really surprised me, and I was trying to think about why, right? And I think it's because it's open source. If I had like my own secret module, and I went, hey, look, use this version of the module, not the, yeah? I won't let you look at the source code, but it's really fast, trust me. You wouldn't install that. It's like, no, I don't trust that. But this stuff is open source, so we just assume that there's enough people looking at it that it's got to be secure. But that package was online for 2 weeks before it was discovered. Okay, so it's really shakes our belief in this kind of open source system. But anyway, npm fixed the problem. Well, they discovered the problem. They then took down this module. It turned out to be a whole bunch of modules that were like this. They turned off. But there could be others, right? There's no way to statically identify a module that might be doing something like this. There's something you can use called NSP, which kind of do some static analysis of your node, of your code, to identify security issues. And if you look at the slides afterwards, there's some nice links which can give you certain scripts you can run to see if you've been affected by this in the past. But there's not really much of a defense other than being very, very cynical and careful and double-checking everything that you're installing. If you are making packages and releasing them, you can do, so this is why we've all seen @Angular. Okay, it's kind of a scoped packages. So on npm, you can kind of own the scope, and then anything underneath it, only you can release. So this stops you from being typo squatted on, but doesn't stop you from being able to, from accidentally installing kind of something like crossenv. Okay, so that kind of scared me, that one a lot, as a hacking story. This is another one. This is something from, I used to work at a company. I don't want to tell you too much information about them. They're a financial startup. I was brought in to help them move to Angular from a very, very old Java framework. It was incredibly old, actually. The Java framework we were moving from had been decommissioned in 2003. The first line of code in this startup was written in 2005. Okay? Now we can laugh, but the startup was sold for 100 million and the founder became very rich, so whatever, right? It wasn't a mistake. But anyway, I was brought in after the startup was sold to kind of help move over to Angular. And obviously it's a financial company, so we've got to reach some pretty stringent levels of security to be registered. So we had some security firms and pen testing firms, and I remember when we hired them, I knew we'd have some problems, but I didn't think it'd be that bad. And we literally hired them, signed the contract, and an hour later, the CTO turned around and went, well, no, they've got something. I was like, you're kidding me? In an hour? And they got it. They basically had figured out a way in an hour to log in as anybody on the platform. And this platform was used by millionaires, billionaires, right? So there's a lot of money flowing through this stuff. So it's pretty scary. And they basically, the vulnerability they went through, the exploit they went through, is something called XSS, so cross-site scripting. And they basically found a way to get the cookie, steal cookies from the end users. So they did it in the way that they did it was very simple. So we had a forum where you could submit comments, and we allowed HTML. So this is what we'd expect somebody to enter. And then when they entered it, we converted it to base 64, and then that went to the server via an API, and we stored that in a database. And then when we rendered the form, we would take that base 64 string, convert it to HTML, and insert that on the screen. It was a server-side rendered application, right? But instead of the HTML, the hello, using Postman, they actually posted this. So, oh, sugar. So what they did was they basically got the cookie, stuffed it in a form, and then just basically submitted the form. Okay? Then what we would do is we just convert that to base 64, and then when the page gets loaded again in the future, we're just showing that script tag. So this is just Stack Overflow. It wasn't Stack Overflow. Okay, I'm just showing as an example. So basically what was happening was that they managed to add a comment onto a thread in the forum so that when somebody viewed the page, just viewed it, that's all they had to do was view the thread. It took that person's cookies and it posted it to their server. All their session information. They didn't have to do anything, just view a forum page. And that was it. That took them an hour to figure out, and they got in. And as I said, that's a type of something called an XSS attack, a cross-site scripting attack. And the goal of a cross-site scripting attack is to run untrusted code in a trusted environment. Okay? It's to trick you into running code, just as it tricked us into running that script tag. So there's a couple of ways to defend against that. If you're running Node on the server side or anything like that, you can use a package like XSS, which you can pass in a string, and if it has a script tag in it or anything it finds vulnerable, it can strip it out. And what we call this is, we call it sanitization. We sanitize untrusted input. And in AngularJS, you have to run stuff like this. You have to run your code through a sanitizer because it assumed everything was trusted by default. Okay, but in AngularJS, in Angular, modern Angular, they actually assume everything is untrusted. So if you've ever tried in Angular to insert something that looks suspicious, like I've had to try adding like a URL to an iframe in Angular, it doesn't because it actually strips everything out. Okay, so in Angular, by default everything is untrusted and it sanitizes it. So in fact, in Angular, if you need to add stuff which is like a script tag, you have to run it through something called a DOM sanitizer, which has various different functions where you can take certain strings and mark them as safe, then they'll get inserted. So something really cool about Angular that I don't think a lot of people know about, that it's actually much more secure than AngularJS, and we're a lot more protected from things like XSS attacks. Another thing you can do is something called CSP. So CSP headers are certain headers which you can send down with your HTML file. And they're certain directives for the browser. So you can set, for instance, a CSP header which says, hey browser, never ever allow any inline script tags. If you see it, just drop them. And you can do, there's a whole variety of things you can set up, and the CSP headers are quite nice in that, as a CTO or anybody in a firm, you can just set up some headers which sets up a security policy, and then you don't even have to worry about what your developers are doing, because if they add any inline script tags, it's going to be ignored. In fact, what will happen is you'll set up a CSP policy, you'll set up some rules, and then all of your code will break, and your devs then have to go and fix it. Okay, so CSP headers is quite nice, but don't just assume one or the other. To create a fully secure application, you have to layer it. You have to have multiple layers of security. So use CSP headers. If you're using AngularJS, make sure you sanitize your import. If you've got a server-side Node application, make sure you use something like XSS to sanitize your import as well. And I think kind of the lesson to learn here is that don't assume your inputs will arrive in the format that you expect. Okay? You're expecting a form comment to only be HTML. It can contain script tags, it can contain whatever. So the solution is to sanitize, either on the back end with XSS or on the front end, and use Csp headers. So just in summary, in conclusion, I'd say 3 things. Number 1, stop pretending. Stop pretending that just because you spent a few moments thinking about security, a few minutes, that you can create a secure application. Make it somebody else's job. Use a PaaS. Don't assume inputs will arrive in the format that you expect. Always sanitize. And did the NPM thing scare anybody? Yeah, oh wow, now I can see hands. Yeah. So, basically don't be trusting, and I don't really have a solution for that, so there's a unicorn. And that's it. If you want to learn more about security, especially on the Node side, my colleague, our colleague Brian Clark, has a what do you call these things? Course on Pluralsight, getting started with Node.js security with Express and Angular. I recommend you take that. It's a really good course. And if you want, remember to follow us on Twitter, Simona and Asim. We'll be posting the slides for this afterwards. And in the slides, you've got links to everything that you want to know, including information about how to secure your application and links for Circle CI in Azure, which you can follow. So that's it. Thank you very much.
So if you have any questions, you can grab us on the hallway. Yeah?
Yeah, I think
Sounds good?
Yeah.
Cool.
Thank you very much.
Thanks.
Another clap.